This first lesson is going to be an introduction to sequences, and we're going to talk just about arithmetic sequences, both explicit and what is called recursive sequences. So first let's talk about some vocab. If you are looking at an arithmetic sequence of numbers, it's basically can you sense the pattern in the numbers? And I'm sure there's a really formal definition in your book, but the way I describe it is it's a listing of terms, numerical terms typically, with a common difference. That's not legible, I apologize. Difference. So as an example, if you start with the number 5 and then you keep adding 10 each time. So 5, 15, 25, 35. So there's a definite pattern with a definite starting point, and our job as mathematicians is to write this in an algebraic notation. So we're going to give you some formulas, and I'm going to give you two different formulas for arithmetic. So the first one is the one that I like to use the most because it's the most user-friendly in my opinion. But it starts with the a sub 1, which is the first term of your sequence, and then you're going to add a common difference to it, but you're going to multiply the common difference by n minus 1. Now this is not going to be simplified if you leave it in this term. So I'm going to give you another formula that's called the explicit form from the computer. So when you look at a worksheet that's computer generated, they always have it in this other form. Basically they simplify it. So they distribute the d, and then they, so this would be dn minus d, and then they collect a couple terms together. So like this first number here is going to be a sub 1 minus the common difference. That's a weird way to say it. And then plus the common difference times n. So either one of these formulas are good, and depending on what you're working with, if it's a computer generated worksheet and your job is to find the common difference, like it's pretty easy to tell in either one of the formulas, but you'll see some examples in a moment where you can see the difference. So a recursive form is interesting because it just basically tells you how to hop from one term to the next. So the recursive form of an arithmetic sequence is going to be a sub n minus 1 plus the common difference. And then they're going to give you a sub 1. So they have to give you a starting point, and then they're going to tell you how to hop from point to point to point. So this term right here is kind of unusual. Recursive means they're going to use the previous term. So a sub n minus 1 is fancy talk for previous term. So for instance, if you need to find the fifth term, you're going to use the fourth term and then add the common difference. It makes a lot of sense when you look at the actual listing, and that's what's hard for kids, is sometimes they see the pattern, just like like my 8-year-old would see the pattern, and she's not going to be able to come up with algebra. But now as juniors and seniors in high school, we're going to be able to do that. So this first question says, is it arithmetic? And if it is, find the common difference. So I try to see if there's a pattern. So I notice here they subtracted 6, and then here they also subtracted 6, and then they keep on with that pattern. So yes, this is arithmetic, and the common difference is negative 6. They're subtracting 6 or they're adding a negative 6 is how we refer to that. Now this one, I get bothered when they flip between fractions and whole numbers because they reduced them. So what I'm going to do is I'm going to compare apples to apples. Essentially I'm going to change 3 to 9/3, and then I can see something as far as patterns go. So here it looks to me like they added 5/3, and they did the same thing here, and then they did the same thing on the next term. So yep, this sure is arithmetic. And the common difference is that they're adding 5/3 to each term to hop to the next term. So this next one, they subtracted 1, and then here they subtracted 4. So right away, no, I can tell this is not arithmetic. My technology is not working out right today. Let's try this again. I'm just going to say no. You don't need a big long explanation as to why. Alright, so now it says find the common difference and the next 3 terms in the sequence. So if you can find the pattern, you can extend the pattern is the idea. So it looks to me like they are adding 3 each time. So the common difference is 3, and then the next terms would be 28, 31, and 34. Yeah? Yeah. Alright, here, again, I don't like the fraction and non-fraction flipping, so I'm going to rewrite these in terms of thirds. So this is negative 6/3, and this is negative 12/3. So I'm looking at the common difference. Looks to me like they're subtracting 2/3 each time. So that's our common difference. And if I keep subtracting 2/3, let's see, that'd be negative 14/3. And then subtracting another 2/3 would be negative 16/3. And then negative 18/3, which is negative 6, would be my last term there. When they want the next 3 terms, of course these go on forever, so hopefully they don't make me do anything too crazy. Oh, like this one. Find the common difference, and then magically figure out the 52nd term. Okay, so there's a couple ways we can do this. We can be very formulaic and use the formula to find the 52nd term, which is not a bad way to do it. And then some kids just think really hard. So this is our first term. This is a sub 1. And I'm looking at the pattern here, and I'm noticing they're subtracting 8 each time. So the common difference is negative 8. And a sub 1 is 3. So you can figure out how to extend the term out to your 52nd term, the sequence out to your 52nd term, by how many times you'd have to subtract 8. That's one way to do it. What I'm going to do is I'm going to show you that formula that we started off with, the one that I like the most, a sub 1 plus d times n minus 1. And if you want to find the 52nd term, basically you're just going to plug in 52 here and here, and you know the first term and you know the common difference. So the 52nd term is, alright, our first term was 3, plus the common difference, oh that's weird, negative 8. And then if you think about this formula here, guys, 52 minus 1, you're not going to subtract 8 52 times from the first term, you're only going to subtract it 51 times, because that's how many times you have to hop to the next term to go from term 1 to term 52. So cranking this in my calculator, which I already did this, so I'm just going to steal my answer. I got negative 405 is my 52nd term. So this notation here just means your 52nd term in the sequence. Definitely not the only way to get the right answer. I just think that's a nice easy way to figure it out if you're stuck. So here, our first term is negative 4. Looks like our common difference is they're adding 20. So again, if I want, you can write your whole formula if you'd like. A sub n equals first term plus common difference times n minus 1. So if I specifically want my 52nd term, I'm going to start at negative 4, but then I'm going to add 20 51 times. That's where the 51 comes from. So type in this in my calculator, which I already did, so I'm going to steal my answer. I got 1016 is my 52nd term in the sequence. Clearly, the way we don't want to do that question is to literally write out, all 52 terms and try to keep the pattern going. That would be silly and a waste of your time. Alright, so the directions say find the explicit formula. So the formula that's going to work for all terms of the sequence. Again, I don't really like that the common denominators aren't held, so I'm going to change this to 24 over 10. I'm going to change this to 54 over 10. And then I can see the common difference is 15 tenths, right? So they're adding 15 tenths each time, which of course reduces to 3 over 2. Okay. So I have the first term, and I have the common difference. So the explicit formula, if you're using that first formula I gave you, would be 9 tenths plus the common difference times n minus 1. Now, the other explicit formula I gave you would be this guy simplified. So they distribute the 3 tenths, they collect some like terms. So basically it's going to be 9 tenths minus 3 halves. Oh gosh. Hello, 3 halves would be 15 tenths, right? So putting these together I get negative 6 tenths, which is negative 3 fifths. Did I do that right? Yeah. That's where I need my kids with me to help me fact check. Alright, negative 3 fifths plus 3 halves gives me n. So that's what happens if you distribute and then collect your non-n terms. So technically both of these are okay for explicit formula, but this is the one that the computer answer key is going to be giving you. So keep that in mind. Alright, first term, I see that the common difference is they're subtracting 8. So I'm going to start with this formula, which is 30. And then instead of plus negative 8, I'm just going to write minus 8 times n minus 1. So again, distributing this, And cleaning this up for the other version of the explicit formula would be, okay, let's see, that's plus 8, so it's 38 minus 8n. This is the version that your answer key will show. Alright, so here, they want us to, I can't read the directions, find the arithmetic sequence. Given the explicit formula, find the common difference in the first 4 terms. So what I like about this version of the explicit formula, these numbers actually mean something. This number right here, this is the first term minus a common difference. And then whatever this number, this coefficient is for the n, this is the common difference. Like, that's how the formula simplifies down. So if it's in this formula, and they say, what's the common difference? Like, it's really easy for me just to say, like, oh, the common difference is negative 200. So if you don't believe me, you can go find the terms and figure it out for yourself. But the first 4 terms would be when you plug in a 1, plug in a 2, plug in a 3, plug in a 4. So the first term, which you can notate as a sub 1 if you'd like, is negative 3. And then the second term, if you plug in a 2, where you just keep subtracting 200 from there, is negative 203. Third term is negative 403. And fourth term is negative 603. That's good notation for the first 4 terms. You could also list them out with commas. Just be careful what you're notating. Alright, this one, same issue. I can see the common difference is that they're adding 2.3 each time. And once you can figure out the first term, it's not too bad. So I'm just going to list them out this time. If I plug in a 1, I get 14.4, and then 16.7, and then 19.0, and then 21.3 are my first 4 terms in that sequence. Patterns, huh? Alright, this might be new. This is called a recursive formula, or a recursive sequence. And they give you a general formula here, and then they give you a place to start. So it says that in order to move along in your formula, you take the previous term, and then you add 2. So they want to know, find the common difference, and then the first 4 terms. Well, the common difference is what you're changing every hop. So we're adding 2 each time. And then the first 4 terms, well, I know a sub 1 is negative 21. So the next term would be taking the previous term and then adding 2. So negative 19. And then the third term would be negative 17. And then the fourth term would be negative 15. Again, I like that notation for the first 4 terms, but if you want to list them, that's okay. So here, this recursive formula says that you take your previous term and you subtract 1.1. So this is your common difference, that you're adding a negative 1.1. So when I start listing out my terms, I start at negative 2.6, but if I keep subtracting 1.1, I get negative 3.7, negative 4.8, and negative 5.9. So patterns, once you write them in algebra, they're really easy to replicate and produce, and we have to take what we sense as a pattern in life and write it as algebra. That's kind of the beauty of algebra, right? Because our end goal is to make the process automated and formulaic, so that way a machine can do it if it has to. Math's cool like that. Alright, so here we're going to write the recursive formula. So first term, obviously we're starting with 16, so I'm going to write down first term is 16. Now for my recursive formula, if I could write it with words, that'd be nice, but it looks like we're just taking the previous term and then subtracting 9 or adding negative 9 to it. And that's what I'm going to write down. So the way you write previous term is you say a sub n minus 1, and then you could say plus negative 9, or you can just say minus 9. My pen will work. I will say minus 9. This is not my day for pens to work, apparently. Try again, Bruzo. There we go. Minus 9. So this right here, that's your entire recursive formula. I know it's annoying that you need 2 parts, but you do. Alright, again, I don't like these missing fraction pieces. So this is really 2 over 2, and this is really 0 over 2. So when I look at sensing the pattern here, the common difference is they're subtracting 1/2. So our first term is clearly 3/2. And then our nth term, they call it, is you take the previous term, which is a sub n minus 1, and then we said subtracting 1/2, or adding a negative 1/2. So this is the recursive formula. I know that looks really crazy, but that's what it is. All right, keep on going. So we have the explicit formula, and they want me to rewrite it as recursive. So you got a couple choices. What I like to do is write out my first few terms, and then I feel like I know what I'm doing. So the first term, if I plug in a 1 here, I get a 4, and then if I plug in a 2, I get a 34, and yada yada yada, and so on and so on. So the first term is important to my recursive formula, and then every term after that can be found by taking the previous term, and then it looks like we're adding 30 to it. So remember, this number here is your common difference. The only thing you have to do a little work for is to figure out your first term, and that's really not that difficult, guys. You just plug in n equals 1. So same thing here. Our nth term and our first term is important. So if I plug in a 1 right here, I get a first term of negative 27. And after that, you're going to be adding 2 every time. So a sub n minus 1, and then we're adding 2. Love it. I don't mind recursive formulas. I don't think they're too terrible. Alright. Oh, this is fun. Find an explicit formula, not recursive. And then they want you to find the 30th term. So, there's your first term. And then it looks to me like we are adding 8 every time. So that's your common difference. So I'm going to write that out. So negative 33, and then we're adding 8 n minus 1 times. Doing a little cleanup here. Let's see, we're going to be subtracting 8. So negative 33 minus 8 is negative 41 plus 8n. So either one of these formulas are acceptable for using, but this is the most simplified one. And then they want the 30th term. So we kind of already did this, right? 30th term would be plugging in a 30. And again, either formula works, so whatever makes you happy. I'm going to go with the second formula. Negative 41 plus 8 times 30. And I already did this on my calculator, so let me steal my answer. 199, yeah. Awesome. We'll show you later how to kind of use your graphing calculator sequence mode to figure out some of these for you. So here's your first term. Looks to me like we are subtracting 2 each time. So starting off with the not simplified explicit formula. And then if you go ahead and simplify this one, let's see, this is plus 2 combined with 36, so 38 minus 2n. So either one of these are good. I prefer the simplified, of course. And then if I'm finding the 30th term, choose your favorite equation. I like the bottom one here. Oh, gosh be golly. I wish I could subtract negative 22. So the 30th term of your sequence is negative 22. So, explicit formula, and then using your formula to figure out some mystery term out there. 30 wasn't really too far out in the sequence. I guess if you were in a jam, you could have just counted out 30, but whatever. Time savers, we like them. Alright, so here. We can just straight up use the formula to figure this out, but I think if we put a little bit of thought into it, we can save ourselves a little bit of grief here, guys. I'm jumping from the 16th term, okay, and then all the way to the 34th term. Alright, so this is 338, and this is 698. So if I think about how I got there, like how many times did I have to add this common difference to go from here to here? Well, it's just the subtraction of these two. So that's 18 steps, right? 18 times we added something to go from 16 to 34. So I call those steps, or jumps, or hops, or something. So if I look at the numerical difference, my numbers, if I subtract those, which I think I already did. I don't know what I did. 360 or something? Yeah. So that's 360 as far as like how far away they are, but over 18 steps. So 360 divided by 18 is a difference of 20, which means that is my common difference. That was definitely not the only way to get the common difference. I just think that's the easiest way, but you know, to each their own and all that. Otherwise, you'd have to go back and find the first term and then go back. I don't know. I don't know if it's easier to do it the other way. I don't think so. So just to kind of, I did that kind of bumpily. So I figured out how many steps we went. I figured out how numerically far apart they were, and I just divided those to figure out the common difference. So, first term. I actually don't have the first term. So what I'm going to do next is I'm going to go backwards and I'm going to find the... Oh wait, maybe not. You know what? I'm not going to do that because I don't want the formula. I need the 27th term. Alright, I'm going to cheat. I know with the 27th term, let's say I start at 698, which isn't this guy the 34th term? So I think about, okay, well I need to back up 7 steps. So what if I back up 7 steps, but every step is 20? Would that work? So let's see, that's 698 minus 140, which gives me 558, 530. I don't know what I just did. Hold on. I need a calculator just a minute. It's totally 558. I got myself nervous because... Oh, jeez. I wrote it like that on my answer key, and I couldn't read it. I thought it said 538, and I got confused. All right, we're good, we're good. All right, moving along here. Let's figure out how many steps we're going. So from the 20th term to the 32nd term, that is 12 steps, right? And if I look at numerically how different they are, and I find the difference between them, well, that's a negative difference, right? It's negative... Where is it at? Negative 1200, looks like. That makes sense. So going back 1200 or taking away 1200 over 12 steps, that means my common difference is negative 100. And then they want the 36th term. So pick your poison here, guys. You can start wherever you want, but let's say we started right here with the 32nd term, which is negative 3062. Well, I still need to move 4 more steps. So I'm going to take away 100 4 times more. So what? That's negative 3462. Nailed it. Alright. I like those. I think those are fun. Given 2 terms, find the explicit formula. So it's kind of like what we just did. So we're going to find the common difference, and then we're going to kind of backtrack and figure out the first term, and then we can go from there. So from 20th to 36th term, that's 16 steps, right? So the common difference is, let's see how far, 3819 to 7019. I know I should be able to subtract that, but I really can't. I don't know why that's so difficult for me right now. It just sure is. Alright, so 32, yeah. So, like this. So what is that, 200? Yeah. Common difference of adding 200 for every step. Alright, here we go. So, what I'm going to need you to do now is figure out the first term. So what I'm going to do is I'm going to start with the 20th term. So the first term is the 20th term, 3189. But I need to back up to the first term. So I need to back up 19 steps of 200. So that's kind of confusing, right? To get back to 1, I'd have to go backwards 19 steps, and instead of adding 200, since I'm going backwards, I got to subtract 200. So doing that on my calculator, which I think I already figured out, that came out to 19. Coincidence that they match, so don't panic. So I have my first term, I have my common difference. Let's do this. So a couple of formulas I will accept at this point. First term plus the common difference of n minus 1. Or if you want to simplify that, let's see, that would be, what's it come out to? Negative 181 plus 200n. So, simplified or not, I mean, if you can get to that point, I'm pretty happy. I'm pretty sure you guys can simplify all right, though. Okay. Oh boy, how many steps are we going here? Think, Abruzzo, think. That's 24 steps, right? And then if I figure out how far away they are numerically, Oh gosh. I don't know. All right, 217, 73. So they're taking away 198 movement points, or whatever you want to call that. If I divide that by 24, something's not right. I typed something wrong. That's not the right number. Oh, dyslexia. I wrote 271, not 217. There we go, 144, like I said. All right, so that's 144. So the common, oh, and we're taking it away. So the common difference is that they remove or subtract 6 each time. All right, so somehow you need to back up to the first term. So the first term would be, let's start at the 16th term, negative 73. But this is kind of confusing. So you're going to have to back up steps of negative 6, which means you're actually adding 6. But figure out how many times, right? To go from 16 to 1, you got to do that 15 times. That was a really confusing way to say that. I'm very sorry. Okay, anywho, what do we get here? We got 17, it looks like. So for my explicit formula, I'll take 17, and then we're removing, or taking away 6 times n minus 1. Or another acceptable version of that would be, let's see, that's a plus 6, so 23 minus 6n. Either formula works. Yeesh, could I have explained that any weirder? I apologize. Okay, next lesson is going to cover geometric sequences.